Hello guys, you're welcome back to Science Arena Academy. Hope you enjoy your days. In today's video, I'm going to be explaining to you my top secret rule that I normally use to answer questions on organic chemistry in chemistry or in Jamb, sorry. Now, these secrets are compounded 5 top secret rule for naming of organic compound, because I saw that many questions, 80% of questions in Jamb are basically under organic chemistry, and some of them that give student problem is the naming of organic compound. So because of that, I came across some rules that you can use, and if you follow this rule very well, you are going to score high in your chemistry in Jamb. Stay tuned. If you are new to my channel, don't forget to subscribe to my channel and also click on the like button. If you love the video, share with your friends. Are we together? Thanks so much. Now let's jump to the topic right now. Thank you. Now, talking about naming of organic compound. You know, most of us will understand that it is known as high-impact nomenclature. Please, let me clarify the fact for you something, is that there is no runs in Jamb. If there is anyone that is lying to you that they are going to give you some runs in Jamb, they are only lying to you altogether. And in this my channel, I will not be lying to you that okay, these are the questions that you'll be expecting in Jamb. I will just tell you through the words. They are most likely questions that you can see in your Jamb, but I don't see questions myself. But I can tell you that these questions, if you understand like this, then you will see likely question of that in Jamb. Thank you so much. Now, let's jump to the rule. Rule number 1 of naming of organic compound. In naming any organic compound, you should take note of this rule. The first one is identify the longest chain carbon. The longest chain carbon. Now, many of us does not understand this. The first thing that you need to do before you name any organic compound is that you need to first identify the longest chain, that is carbon, that is there. Altogether, if you're able to identify the longest chain, then you knew okay, because the longest chain carbon will give the name of the compound. Altogether, that is rule number 1. Rule number 2 is that we have to identify a functional group, or let me say identify the functional group that is there. Now, you see, these two are the most important thing. The first thing is for you to identify the longest chain. Then the second thing is for you to identify if there is any functional group there. Because a functional group determines the full name. It works with the longest chain to determine the full name of the compound. Take note of that. Now, the likely functional group that you might have, let me try to give you. These are the likely functional group. If there is any functional group, we know that, okay, we can have a double bond as a functional group, which is any compound that have a double bond, we know that they are what? Alkene functional group. They are alkene. We can have a triple bond, which is what? Alkyne. We can have OH is a functional group, which is hydroxyl. We can have NH2, which is amine. We can have COOH, which is ethanoic. We can have CO as a functional group, which is what? Ketone. We can have CHO as a functional group, which is what? Alkanal. This one ended with what? Alkanal. While this one is what? Hydroxyl. And this one is amine. We can have this as alkanoic. Acid is an acid, or we call it carboxylic acid. I'm going to be giving you some rules of naming this also. We can have the ketone, which is what we can also we call it the ketone altogether. Now we can also have some likely ones of hydroxyl, amine, CHO. We can also have O, which is a fuzzy group altogether. Now take note, these are likely functional group that you might see in Jamb. So this functional group, first thing is for you to identify, is there the longest chain? If you know the longest chain, then identify the functional group. If there is any of this functional group, it determines the name. For example, if the longest chain carbon is 4, we know that 4 carbon simply indicates boats. All together. Now we now check the functional group. Is there any functional group there? Sometimes the functional group might be a single bond. A single bond is might be what? A single bond, which is what? Alkane. Now, if the functional group is a single bond, we can say what? It is butane for 4 carbon. But if the functional group is double bond, we can say it is what? Butene for 2 carbon for 4 carbon. If it is hydroxyl, we can say it is what? Butanol. Because all hydroxyl must ended with ol. Alkyne must ended with ein. Alkane must ended with what? In. Alkyne must ended with an. So if it is alkyne functional group CHO that you see there, it will be what? Butanal. Butanal for 4 carbon. So like that, we can have what? Butanoic. We can what? Butanamine. All together. Lamine. We can have what? Butanone. Are you getting me? Because this one ketone, we call them what? Acanone. Acanone, and they ended with what? 1. Are you getting me? Butanone. Altogether, butanone, which is for acanone. Are you getting me? Now, we also have what? Alkoxyl compound functional group. These are likely functional group. So, if you have been able to identify the word functional group, then the functional group must be joined with the longest chain to determine the name of the compound. That is one thing that many students don't know. I'm coming back. The third thing is for you to identify if there is any substituents. Substituents. Now, let me now explain to you substituents. Now, we can have different kinds of substituents in organic chemistry. We have what we call the organic substituents and the inorganic substituents. Inorganic substituents. Now, what is an organic substituent? Organic substituents are majorly alkyl group. Alkyl group. Now, what are the alkyl group that we have? The alkyl group are the methyl, which is CH3. Whenever you see CH, the methyl, we can have ethyl, which is what? C2H5, and so on and so forth. So these are the what alkyl. We can have what? Propyl, butyl, pentyl. So far they are ended with what? Have a high. Alkyl or what? Ethyl, methyl. So each of these are organic functional group. But you see the inorganic functional group are well known. The inorganic functional group are majorly halogens. They are what? Halogens. Now, the halogens such as your fluorine, F or chlorine, Cl, bromine. These are the likely ones that they give. Bromine, Br, iodine, which is what? I. All together. Now, these are the what? Inorganic functional group. Now, whenever you see this inorganic functional group, please take note. Their name is not taken as fluorine. If you want to call them, they ended with O, which is fluoro. They can be given as fluoro. This one is chloro. This one is bromo. This one is iodo. All together. Now, we need to identify these things. Is the substituent is the substituent an organic substituent or an inorganic substituent? I'm coming to the best thing that you can use to name the organic compound. But before I identify each of these, now after identifying these 3 things, now how do we now name the organic compound? It now depends. The first thing in naming, after you've been able to identify the chain, now you check something. The first thing I need to do is that compound having a functional group? And what is the functional group? If the functional group is high, are you getting me? And many things that many people does not understand that words. Majorly, alkane is not a single bond, is not a functional group. Functional group started from what? Alkene, which is double bond. Starting from alkene downward, their functional group. Because the rules that I'm going to be given here will not be applicable to what? Alkanes. Are you getting? Well, you can name alkane normally. Now, how do we now name it? Take note of this. If you are to name any organic compound, the first thing I need to do is that what? Is there any substitute? The first thing is for you to know the what? Number of carbon, which is the what? Name of the compound. That is the first. Know the number of carbon. If the number of carbon is 4, that is butane. Buts. If the number of carbon is 5, that is pent. If it is 6, it's X. If it is 7, it is X. If it is 9, it is what? Oct. They not depend on the final name. Is it an alkane compound or an alkene compound? An alkane compound made us understand that it's a single bond. That will be everything is single bond. An alkene compound made us understand that it was double bond. All together. Now, the next thing after that is now to identify Hello, if there is no functional group there, then you move on to the substituents. If you do not see any functional group, I mean, you do not see double bond, you do not see triple bond, or you do not see other functional group that is there, then move on to the substituents. What are you going to do to the substituent? Don't forget that we said the substituent might be organic substituent or what? Inorganic substituent. Now, if you are to name the substituent, an inorganic substituent must be given the lowest numbering. Okay, let me take it like this so that I will not get confused. If the substituent that is here is only organic substituent, then that substituent must be given the lowest numbering. It must be given the what? The lowest numbering of carbon. Altogether, let's take an example on this first thing. Assuming the substituent is an organic substituent, you must make sure that that substituent is getting the lowest numbering of carbon. Take for instance, assuming I have a compound of this kind, we have CH3 here, and we have CH3 here, and I said I have what CH, okay, don't let me put this, CH3, I have C, I have H, then I have C, H, and H. Now, look at this compound here, I have H in this place here. How do we name this compound? Don't forget that there is a substituent. What is a substituent? A substituent are majorly attached to the edge of a carbon. Are you getting that? Not the side way. Sometimes something might be what side way. Now, let's name this compound. What is the first rule? The first rule said identify the longest chain carbon. What will be the longest chain here? If I try to name this compound like this, we have 1, 2, 3, 4. This is 4 carbon. If I go like this, 1, 2, 3, 4, it is the what? Same 4 carbon. So I can pick this as my longest chain because it's going to give me the same number of carbon. So this is my longest chain. Altogether, now if I'm picking this as my longest chain, any carbon that is either above or below will be taken as a substituent. Now I have this substituent, but since it is CH3, is an organic substituent which is known as what? Alkyl, and it is methyl or methyl. Altogether, this is what? Alkyl substituent. Now I have now numbered the carbon. How do we now number the carbon? Am I going to take the numbering from the right or the left? According to the rule that I gave, rule number 1 is that what? You have to number the carbon in such a way that a substituent will have the lowest numbering. A substituent. That means something might be organic or inorganic. So a substituent might be what will be having the lowest numbering. Now, since this is the substituent, if I name from here, we have 1, 2, 3, 4. This substituent will be having the what? Highest numbering, which is 3. But if I name from here, if I name the other way around, 1, 2, then this substituent will be falling on what? Carbon 2. So how am I going to name it? I'm going to name from the right to the left. From the right to the left. Because from left to right, it will make carbon to be 3. The substituent will fall on carbon 3. But from right to left, the substituent will fall on carbon 2. So the name of this compound should be equal to what? 2-methyl. Altogether. Now, don't forget that I said you've already identified the longest chain. Since the longest chain is 4, and there is no functional group there, so the longest chain is 4, 1, 2, 3, 4. Then we know that the name generally is what? Butane. Butane. See, there is no other functional group that can change the name from A, maybe to in or ein altogether. So it is what? 2-methyl butane. 2-methyl butane. Now, this is the name of this compound. That is rule number 1. Identifying the longest chain and also identifying the what substituent, if there is a substituent there. If there is a substituent, make sure that what the numbering of the carbon must give the substituent the lowest numbering altogether. Now, the next thing I want you to take note is that what? The substituent might not be organic substituent. Are you getting me? If the substituent is not an organic substituent, let's say the substituent is another thing else. Let's say, let me try to put it here. I have a substituent of what? Bromine altogether, or it is chlorine. All these are inorganic substituents. The same rule prevails. Altogether, what is the rule? You need to give the what? Substituent the lowest numbering. So what will it be? Instead of for it to be what? Methyl, it's what? 2. This is 2. Because I'm going to count from here. 1, 2, 3, 4. So it will be 2 bromo. Are you getting 2 bromo butane? 2 bromo butane. Now that is the name of the compound. I'm sure that we understood this. That is number 1. Number 2 that we need to take note is that what? If that is rule number 2. Rule number 2 is that what? If the substituents are occurring more than one, how do we name it? That means if I have more than one substituent, either it's organic or inorganic. If I have more than one substituent in the compound, how do we name it? Now, more than one substituent in a compound, you need to give them another name by what? If it is two substituents that is there, then we're going to give it what? Di. If it is three substituents, it's going to be what? Tri. If it is four substituents, it's going to be what? Tetra. Tetra. All together. Now let's take a look at this question that is here and then their position. Now, let's take a look at this. Assuming I have CH3, CH, we have CH also. I also have CH2, and then I have CH3. Now, in this case here, in this first carbon you have what? Cn, and then in this place I also have what? Cn. Now, how am I going to take my numbering? First of all, let's identify the longest chain. The longest chain should be, since there is no carbon above and there is no carbon below, the longest chain should be 1, 2, 3, 4, 5. And again, another thing I need to know, is there any double bond? No. Is there any of this functional group there? No. Altogether, so there is not any single functional group there. Then this name should be 1, 2, 3, 4, 5, which is pentane. The family name is pentane. Now we know it's pentane. Now, the next thing I need to deal with what? We need to deal with the substituents. Do we have any substituent there? Yes. This is a substituent. These are other substituents. Now, how am I going to name? Number. We need to number such that the substituent will be having the lowest numbering. Now, if I'm numbering from here, 1, 2, 3, 4. This substituent here will be having 4. Why is it will be having 3? Which is too much. I can now start my numbering from here. 1, 2, 3. Then this substituent here will be having what? 2. And this one was 3. Then 4, 5. So this is the lowest number, 2 and 3. But if I count from here, 1, 2, 3, 4. This has the highest number, which is 4. All together, so we can take our counting from here. Just make sure that what, since this one can still get the lowest number, we'll count from here. It's going to give one of them the lowest number. So this is it here. Now, how do we now name it? Since the two substituents are attached to different carbon. All together. So the first one is attached to carbon 2. The second one is attached to what? Carbon 3. We are going to indicate that in their name to showcase. I will say the compound is 2, 3. That means showing that what? First one is on carbon 2. Second one is on carbon 3. 2, 3. Now, since there are 2, I said if there are 2, we are going to use the word di. So 2, 3, di. Now, don't forget that they are not methyl. What kind of structural group are they? They are inorganic substituents, which is chloro. So dichloro. Chloro. Altogether, dichloro. Now, what is now the main name? Since there is nothing there, what's the main name? The main name is what? Pentane. Dichloropentane. Altogether, so 2, 3 dichloropentane. That is the name of this. I think I've been able to explain something better. Take note of that rule. Now, rule number 3. The third rule is now, if the substituents are mixed substituents, the inorganic substituent must be given preference to the organic substituents. Now, when we said mixed substituents, what do I mean mixed substituents? Mixed substituents simply means in a compound whereby we have organic substituents, and we also have what? Inorganic substituents. Inorganic. Organic are your alkyl. Inorganic are your halogens. Are you getting me? Or halides. Now, if I have a mixture of an organic compound, an organic substituent, and an inorganic substituent in a compound, how do we name it? Then you need to what? A preference will be given to an inorganic substituent. That means an inorganic substituent must be named first before the organic substituent. What does that mean? Simply means if you are to give the lowest numbering of carbon must be given to the inorganic, a carbon that is carrying the inorganic substituent, not the one carrying the what? Organic substituents. Are you getting what I'm saying now? That is what is that. Another thing that I want you to take notes, let me take this as rule number 4. Rule number 4 states that if you are having a mixture of something like that, then you need to name them alphabetically. That means, for example, I have bromine, I have chlorine, and I also have what? Methyl. Don't forget, if I have the same substituents, bromine and chlorine are the same substituents. I get inorganic. But bromine is there, chlorine is there. How do we name it? We are going to name it alphabetically. B comes before C. All together. Now, let me give an example on this rule that I just gave just now. This is it. Assume I have a compound of this kind. I don't want something that is tough. Okay, let's say we have something of this kind. We have CH3. I have CH. I have CH2. And I have CH. This one is carrying bromine. I have C. It's carrying Cl. And I have CH3. Now, this is the compound that I think I have CH3 here also. Now, how do we name this compound? Where will I start my numbering? Am I to start my numbering from the right, from the left, or from the right? Now, don't forget my rule. We have a mixture of different substituents. But before you name it, first of all, cross-check, because the rule might vary. Cross-check. Is there any functional group? Look at everything. Make sure that everything is single bond before you start using the rule of substituents. Are you getting? If a functional group has been identified, then the rule works. We know what to use that same rule again. Now, there is no any functional group there, then I can use the rule of substituents. Now, let's not check again. What is the longest chain? The longest chain is 1, 2, 3, 4, 5, 6. Abi? Since there is no one, if I count like 1, 2, 3, 4, 5, 6, it's the same 6. So I'm going to take this as the longest chain, longest straight chain. So since it's 6, well, I know it is what? Hexane. It's hexane. Since there is any functional group there, it is what? Hexane. Now, let's now name it. We have a mixture of substituents, bromine here, chlorine, and methyl. Methyl. Are you getting something now? Now, I will not be numbering my carbon from here. Why? Because if I number my carbon from here, this inorganic substituents will be having the lowest number, will be having what? Highest numbering. And according to my rule, the rule states that what? The inorganic substituent must be given preference than the organic substituent. That means if I'm to name number, I will number such that the inorganic substituent will be having the lowest numbering. So I'll be starting my numbering from here. 1, 2, 3, 4, 5, 6. So can you see that this one is having the lowest numbering, the inorganic? Now, after you've been able to understand that rule, then the next thing is now for you to name it. If you now want to name it, you've been able to count the number of carbon, then naming is now that you are going to name them alphabetically. B must come before C, before M. This is methyl, M. Altogether. So how I'm going to count it, it is 3 bromo, altogether. Bromine is named for because it's what? B. 3 bromo. Then I'm going to name this one what? 2, 2. To show that what? This 2 means that the chlorine is found on carbon 2. The both of them are found on carbon 2. So 2 dichloro. 2 dichloro. Then I'm able to name all this. Then the next one is not naming this. This one will be what? This is found on carbon 5. We cannot say 5 methyl. 5 methyl. All together. What is now the name? Hexane. So the compound is 3 bromo, 2 dichloro, 5 methyl hexane. That is how we use that rule. Rule number 4. Okay, I think this should be rule number 5. Rule number 5. A functional group that is found in a compound must be given preference to a substituent. Altogether, a functional group in a compound must be given preference to a what? Substituent. What does that mean? Simply means one will see a functional group. You know, I said the functional group might be double bond, triple bond, or alkanol, or any of them. Whenever they are found in a compound, you are going to number the carbon. You are going to give a carbon that is carrying that functional group the lowest numbering. The carbon carrying the functional group must be having the what? Lowest numbering than any substituent. Even though there is a substituent that we are not concerned. But make sure that the carbon that is carrying that functional group has the lowest numbering. Let's take for an example of that. So I'm sure that with my this 5 rule, you should be able to win any question on organic compound naming. Now, take a look at this. I have this compound C, 1, 2, 3, C. And then CH2. We have CH. And I have CH3. CH2, and I have CH3. So I should be having another C. Oh, sorry. I have CH3. Then I have CH3, and here's CH3. Now, how do we name this? Forget about this one that is here. The first thing I need to know is that what? The functional group, is there a functional group there? Yes, a triple bond. And this functional group will be used to determine the name of the compound. Altogether, now let's identify the longest chain carbon. If I count like this 1, 2, 3, 4, 5, 6, 7, 8. If I count like this 1, 2, 3, 4, 5, 6, 7, 8. Like this also 8. Altogether, so I will take the longest chain as what? Longest chain of the compound, which is 8. That is octs. Octs. I don't know, maybe it is N or ein. It should also be octine. But you don't name it directly as octine. This octine simply means the triple bond is on carbon 1. Are you getting it? Now we need to go and identify where that functional group is located before you give the word family name. Altogether, now I'm going to take numbering to make sure that that functional group will have the lowest numbering. Altogether, it's going to have the lowest numbering. How do we count it? If I count like this, 1, 2, 3, 4, 5, the functional group will be on carbon 5. But if I count like this, 1, 2, 3, the functional group will be on carbon 3 because this is the carbon before the functional group is what? Owner of the functional group. This functional group will be on carbon 3. So counting like this will give us the lowest counting. So I'll count here 1, 2, 3, 4, 5, 6, 7, 8. Altogether, now what will now be the family name? Since the 8 simply means octs. Altogether, now the functional group is on carbon 3. We are going to say oct3. Now, since the functional group is triple bond, you know it is going to be what? Ein. It is triple bond. So the family name is now what? Oct3ein. We know that the functional name is oct3ein. Now let's now name the substituents. The substituents, since that you've already numbered it, then the substituent should be what? I have the same organic substituent of this, and this, but on different carbon. So how will you name it? It is what? 2. The first 2 are in what? The same carbon. I mean, that is 2, 2. The third one is on what? Carbon 6. 2, 2, 6. 2, 2, 6. That is 2, 2, 6. Now, since there are 3, we are going to use the word tri. Are you getting? What functional group are they? Methyl. That is methyl. Are you getting now? Now, 2, 2, 6 trimethyl. What is now the name? Oct3ein. 2, 2, 6 trimethyl oct3ein. 2, 2, 6 trimethyl oct3ein. Altogether, we've been able to name this compound, even though it is kind of what? Tough to name. Let me share you another interesting thing that you need to know. Now, you see, let me look at another functional group because, oh, sorry, I think I gave rule number 4. Then rule number 3, the number 5 is that there are some functional groups that have preference than double bond and triple bond altogether, and which give us the 5th rule. The 5th rule states that what? Whenever you have a functional group which are compounds like hydroxyl, amine, COOH, which is alkanoic, I get me, ketone, they are compound. A functional group in front of the compound, are you getting what I'm saying now? Or a functional group in front of the radicals have higher preference than a functional group that are what? Double bond and triple bond. What does that mean? Simply means whenever I come across a functional group that is in front of a compound, I must give preference to them than a double bond or triple bond. Let's take a look at that example in this case so that you can understand what I'm trying to say. I think I have let me check something. Okay, let's take a look at this. I have CH3, double bond CH, CH, that one CH, I have CH and then CH3 here. Then I have CH2 and I have CHO. Now, take a look at something here. All these things are, this one is not CH3. This is a functional group, which is, the functional group name is alkanal. Alkanal. Whenever I have CHO, it's alkanal. Whenever I have CO, it is alkanol. Sometimes they write like C double bond O, alkanol. But this one is alkanal. Now, I have two functional groups here. This one functional group, this is another functional group. But this one is a radical functional group. While this one is a bond as a functional group. So a radical functional group has higher preference than a bond as a functional group. That is what the fifth rule is talking about. So if you have to name it, you have to start your numbering by making sure that the radical functional group we have in the lowest numbering. I will not count from here. What will I count from? 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. Now, what will not be the name? The general name, because this is the longest chain. The general name will not be what? But in this case here, please, it doesn't, because, hello, this one has higher preference than this for numbering. But if I'm to write the name will be name of this combined with the name of this. We know that this one should be I. This one should be I. I get what now? This one is what? I. Sorry. This one is in. Why this one should end with what? Al. You know that all alkanal must end with al. Etin, this is double bond. Etin must end with what? In. So, if I'm to give the family name, then the family name will not be the combination of this and this. Are we together? How do we now? But this one will be the last name. How do we now name it? Let's take a look at the family name. We have 1, 2, 3, 4, 5. Are you getting what I'm saying now? This is 5. The double bond is on carbon what? 4. Don't forget, these are substituents. Let's name the substituents. Now, what will be the general name? What will be the name of the compound? The name of the compound is what? This double bond is on what? Carbon 4. We will say what? I'm coming. We are going to give this. Okay, yeah. So this one should be what? The name is 1, 2, 3, 4, 5. That is pents. Now, I want to name, this one will carry the final name. Why this one here, I will name this before I name it, although this one is final name. I get something now. Now, I use this one for counting. But if I want to name, I will come on name this double bond. What is this? The double bond is on carbon 4, which is pents 4. Are you getting something now? Now, it should be for in. If there is no, if I didn't have this one there, it will be pent 4 in. Are you getting something now? But because of this now, it's not of pent 4 in. Then this one is on carbon 1. I don't need to write 1 al. So what will it be? Pent 4 in al. Since that is on carbon 1, we are going to just write the name al. So the name of this family is pent 4 in al. In al. All together, because the general name of this one is al. So pent 4 in al. Now let's now add this one here. This one is on carbon 3. That is 3 methyl. 3 methyl. So it is 3 methyl pent 4 in al. 3 methyl pent 4 in al. That is the name of the compound. 3 methyl pent 4 in al. Let's try one more time so we can know what we are doing. Okay. Let me try to check. Okay, let's take a look at this. CH3, C, CH3. We have the one CH. We have CH2. I have CH. Then we have OH, and I have COOH. Now, a problem lies in this. How do we name this? What will be the family name? Now, first of all, is there any functional group? Yes, this is a functional group, But this functional group here is a carbon functional group. Are you getting? It has privilege more than ordinary, the one that does not have carbon. Now, this is another functional double bond. Then I'm going to count such that this functional group, are you getting, must have the lowest than this, and although this one here is acting as a substituent in this case here. And whenever OH, if OH is to act as a functional group, it should not be in this place, they will put it here. It's acting as a functional group. Are you getting what I'm saying now? But if it is going to act as a substituent, it will be attached to either vertically or either vertically to what? To a carbon. So if it is not attached vertically to a carbon, we will not call it on again. Rather, we write it as hydroxyl. Hydroxyl. Are you getting me? It is an hydroxyl. Why? Because it is acting as a substituent, not a functional group in this case here. Are you getting me? So the only functional group that we have is one oik. Oik. This is an oik functional group. And also we have the what? In functional group. Don't forget, the both of them should be writing together in oik. In oik. In oik. Are you getting? But if I want to number, I will number starting from the what? Oik. I'll give out 1, 2, 3, 4, 5, 6. The oik must have the lowest numbering. So let's now name, what will be the name? The name of the family should be, on what carbon is the double bond found? 4. I mean, what is the general name? 1, 2, 3, 4, 5, 6. That is eggs. Are you getting what I'm saying? Now, the eggs, right? Now, the double bond is found on carbon 4, right? That is eggs 4. Eggs 4. Are you getting me? In oik. X4 in oik. Don't forget I say it's going to be what? In oik. Why? In oik. But I don't know that in is on what carbon? See, the in is on 4th carbon. I will need to put the number of carbon there. 4 in. Actually, the oik is also on a carbon, like the second carbon. Then we can say S4 into oik. But it's on the first carbon. I just say X4 in oik. Now, that is done. The next thing is now, in this case here, this is now serving, because it's serving as a substituent. What kind of substituent are we going to call it? We are going to call it an inorganic substituent. Inorganic. Why this one is an organic substituent? Are you getting me? Now, hydro and met, H and M. This is H and this is M. Which one will come first? H will come before M. All together. Now, let's take a look at the numbering of this. So, what will now be the completion of this? It is not what? The H is on carbon 2, that what? 2 hydroxyl. Are you getting me? The H3H3 is on carbon 5, that is what? 5 methyl. 2 hydroxyl, 5 methyl S4 in oik. 2 hydroxyl, 5 methyl S4 in oik. Now, to find this oik, anything that you see COA is an acid. So, in oik acid. So, it is 2 hydroxyl, 5 methyl S4 in oik acid. 2 hydroxyl, 5 methyl S4 in oik acid. Let me give one more example that deals with what? Another position of the double bond. Let me try to cross-check if I could see any question related to that. Okay, let's take a look at this. Okay, let me take a look at this. We have CH3, CH2, I have CH, then I have CH3, CH2, CH3. Then on this one, I have CHO. Yeah, CHO. Yeah. How do we now name this? Please, if we are to name it, this is going to give us a tough problem. The problem is that so far they put this thing in this place here, doesn't make it a substituent. Altogether, it will determine the name of the compound. Are you getting what I'm saying now? Now, in this case, I want to number. I need to number such a way that it's going to be having the lowest, not this one. Altogether. Now, what will it be? 1, 2, 3. No, 4. It's going to have the highest. So, if I count from here, 1, 2, 3, 4, 5, 6. So, this one will have the lowest. Now, 6 simply means hexane. All together. Now, how am I going to write the name? The name of the family will be what? X. I get it. Now, the functional group is on what carbon? Carbon 3. So, I will now write them as what? X3. You know, it's just an, 9. Supposed to be hexanal. Supposed to be hexanal. Assuming there is no position, assuming it is ordinary, this is on carbon 1, I'll just take it as hexanal. But since it's on carbon 3, it should be what? Hexa 3, 9. Hexa 3, 9. To show that it's acanal functional group, X 3, 9. All together, sorry, hexa, not X. Hexa 3, 9. Now, we've been able to get that. Then we'll now locate this one, substituents, which is on carbon 4. They will now write what? 4-methyl. 4-methyl hexa 3, 9. 4-methyl hexa 3, 9. I hope I've been able to explain the differences that is found between what? The functional group. How to name a functional group. If there is anything that you find difficult, you can just message me directly. Drop a comment for me in the comment box section. I'm going to attend to your question. But before I go to them, I'm going to give you a compound to name for me. Name the compound and send me, using the same rule I gave to you, drop your answer in the comment box section. I want to see your answer. Let me write the question on the board. I have this CH3, CH, then I have double bond CH, single bond C, double bond O, single bond CH, and here I have CH3, and then I have CH3. This functional group here is ketone, so his own is always ended his own 1. So the name of the compound must end with 1. So that is 1. That is the first question. The second question I want an answer for is this: CH3, CH. I have C, double bond C, H, Cl. This is another question inside this. This is double bond O, Cl, CH. Double bond CH, and here we have COO, CH3, 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 CHC, CH, single bond COO, CH3. Now, if you know the answer to this, drop the answer for me in the comment box section below. Thank you so much for watching. See you in the next episode. Thank you.